So let's continue with our discussion. So far, we have dealt with volumes and lateral surface area of solids. So this time, let's consider what we call similar figures. And when we talk about similar figures, these are actually similar polyhedrons. Oh, yeah. Are polyhedrons that have the same number of faces, respectively similar and similarly placed, and have their corresponding polyhedral angles equal. Corresponding lines of similar figures are proportional. Okay. When we say similar figures, they are actually of the same shape, so same number of sides, same polyhedral angles, the angles here are equal. So, magkaiba lang yung size. Okay? So, ibig sabihin, like in this first figure, if you will now try to make this larger, there will come a time that this polyhedron will be exactly the same as this. So, similarly with this cylinder, if the cylinder is similar to the cylinder, you can now try to enlarge this until you come up with this exact same cylinder. So, those are our similar figures. And what is important is this. The areas of similar plane figures or similar surfaces, okay, S and big S, so small s is for the smaller figure, big S is for the bigger figure, have the same ratio as the squares of the corresponding lines X and X. We are looking at areas, you can now get some lines on those figures, but you have to square also the ratio for that. That's why you now have this relationship. Okay, and then the volumes. So you have the volume of the smaller figure, volume of the bigger figure, have the same ratio as the cubes of the corresponding lines X and X. So you have uh, the volume of the smaller figure is proportionate with the volume of the bigger figure, and then you have to cube the corresponding side of the smaller figure, and it must be proportionate with the cube of the corresponding side of the bigger figure. And in similar figures of any kind, pairs of corresponding segments will have the same ratio. So basically, when we are looking at similar figures, we are just using the principle of ratio and proportion. But then again, if the problem is involving areas, we square the corresponding sides that we are looking at. If the problem involves a volume, we look at the corresponding, or we get the cube of the corresponding sides that we're looking at. But if we will just be considering corresponding sides of the two figures, then they will simply be proportionate with each other. Let's now go to an example here. Again, the example that I'm discussing here are already from your module. Let me just explain some of the problems there. So find the volume of the shaded area. So this is our shaded area. So if you will look closely in our diagram, we have two similar figures. We have the smaller pyramid and we have the bigger pyramid. The height of the smaller pyramid is 15, while the height of the bigger pyramid will be 30. This is equal to 10. So it's the side of one of the this is a square base, so one edge is 10, while the 10 centimeters here is this section. This section. Okay. So uh how do we now get the volume of this shaded region. So if we will consider the volume of the shaded region, volume will be volume actually of the bigger pyramid minus the volume of the smaller pyramid. Agree? Get the volume of the bigger pyramid minus the volume of the smaller pyramid, then you will get the volume of the shaded area. How do we get the volume of the bigger pyramid? So from the previous lesson, volume is one-third base times height. Okay? So volume of the bigger pyramid first. It will be base. Do we know the base? Not yet. We don't know the base yet. Times the height. The height is already given. It's equal to 30. So volume of the bigger pyramid is one-third. Okay. The area of the base, since that's a square, so if we will call this as x, that must be x squared times the height, which is 30. While the volume of the smaller pyramid will be one-third area of the base, we know the length already of one side, that's 10, so that's 10 squared multiplied by the height, which is 15. So what's missing? What is missing in this problem is the value of x. So how do we now find the value of x? That's where similar figures will come in. So how do we solve for x? To solve now for x, we use the principle of similar figures. So what can we have here? If you will look at the height of the smaller is 15, while the height of the bigger is 30. So that's the existing ratio. 15 is to 30, or that's actually equal to 1 half. 15 over 30. Now, since these are similar figures, so this side here must also be proportionate with this side here. So that is 10, while 10 is to x. So sabi nga natin kanina, again, where did we get 15 over 30? So we have the height of the smaller is proportionate with the height of the bigger, and the base of the smaller must be proportionate with the base of the bigger. So this is 1 half is equal to 10 all over x. So if we will now cross multiply, x will be equal to 20, 20 centimeters. So if x is 20 centimeters, therefore this will now be one-third times 20 squared times 30. So you can compute the value of that, and then you can also have the value of this. And if you now have the volume of the bigger, then just subtract the volume of the smaller. That will give you now the volume of the shaded area. Okay. So next thing that we will be discussing is our conical surface. So we just did not include this under pyramids because a pyramid is defined as uh, a polyhedron wherein the base is a polygon. Okay. Now for a conical surface, so a conical surface is a surface generated by moving straight line or generator which always intersects the fixed plane called a directrix, and which always passes through a fixed point called the vertex, not in the plane. Okay, so parang sinasabi dyan, parang to, pag titingnan nyo itong diagram na to, if you will draw a line coming from this point, this will now be called the vertex. Okay, so get that line, parang diniretso niya lang, di ba? So if you will imagine, if you will rotate this, as you rotate that, this section will also rotate. Okay, so the figure the figure formed there, so according to that, will now be called your conical surface. So it's a surface generated by a moving straight line here, right? Di ba? This is the straight line. You're moving this. So ito yung surface na mabubuo. So that's what we call the conical surface. It will also be the same as this surface here. Don't worry about the definition of directrix. We will be uh, refreshing ourselves with with the definition of that when we get into the conic section. Then, a cone is a solid bounded by a conical surface. Okay, so in these diagrams, where do you find your conical surfaces? Ito, you have your conical surface here, and here you have a conical surface also. So whose directrix is a closed curve and a plane base, which cuts all elements. Okay, so this is now your base. This is also your base for the second diagram. Now the altitude is defined as the perpendicular from the vertex to. Also, if you will get, let's say, this as the perpendicular line coming from the vertex, then this will now be the altitude or the height. So in this diagram, if you get the perpendicular line coming from the vertex to the base, you get your altitude h. And additional definition here, if your base is a circle, okay, then you call your cone as a circular cone. So, ibig sabihin, pwedeng yung base natin is not a circle, pwede siyang ellipse or parang oblong. Then, for our formulas, similarly, the volume is 1/3 base times height. So if you have a circular base, then your base is pi r squared. And in this discussion, we will be limiting ourselves with circular cones so that we have the base as a circle. Uh, because hindi pa natin na-discuss yung ellipse, so we will exclude problems wherein the base is not a circle. So again, in our discussion, we will just be limiting ourselves wherein the base is a circle. So pag titignan niyo yung formula, pareho lang nung sa pyramid. Nagbago lang yung area ng base. So this time, our base is a, in this case, sabi nga natin, we'll limit ourselves with circular cones, so circles. Then the lateral area, same concept with our pyramid, but since we will no longer see our uh, lateral faces, yung mga triangles, ang magiging formula natin ngayon is, di ba kanina is 1/2 perimeter times the slant height. So ngayon, ang mangyayari, instead of using perimeter, since nasa circular base ang i-consider natin, then the counterpart of the perimeter kanina is now the circumference, which now will be 2 pi r, di ba? Times 1/2. Kaya yung 2 and 2 will cancel out. Kaya yung lateral surface area is pi r L, where L is, again, the slant height. Yung slant height, pareho lang nung pagka-define natin sa uh, pyramids kanina. Okay, so let's have this example. The vertex of a cone is shown in the figure. So the vertex of a cone is shown in the figure and it is located at the midpoint, again, midpoint of an upper edge of a cube. So cube 12, 12, 12. So this must be 6 and 6. Then the base of the cone is a circle inscribed in the lower base of the cube. So if the base of the cube is 12 inches, so this must be 6 inches, find the volume of the cone. So volume by formula is 1/3 the area of the base times the height. So we need two things. The area of the base. Since the base is a circle, we need its radius. So if that's your your base, inscribed yung circle. So if you get the center, if you draw a line that will now connect the point of intersection, that will be the radius. That will be the radius. What will be the length? That should be 6 because it's the center of the circle. It must be the center also of the square base. So that must be 6. Therefore, the base is area pi r squared, and then we compute for h. So I think we already have the value of r, which is 6 inches. So that's pi times 6 squared times h. But what will be our h? Go back to your diagram. So this is your vertex. If you now drop a perpendicular line to the circular base, it should intersect there. This is your, talagang ayaw mag-straight line. Anyway, just imagine that that's a straight line. That's a straight line. Now let's try to attempt drawing a straight line again there. Let's see. Oh, talagang ayaw. Anyway, so where do we draw our straight line there? So from this point, we drop a perpendicular line. Oh, that's better. It must intersect in the point of intersection of the circle and this edge. Therefore, this must be 12 also. Thus, that will now give us the altitude of the cone. So we're also having now the value of h. And then just compute the values or the value, you now get the volume. Another problem given in your notes also, or in your module, how many square yards? So how many square yards of canvas will be required to make a conical tent? Conical tent 15 feet high, 15 feet high, and diameter is 18 feet. So if the diameter is 18 feet, then the radius is 9 feet. We'll look at this part later. If 10% of the material is wasted. So how many square yards of canvas? So when we are talking about the material to be used here, it must be referring to the lateral surface area. We don't look at the base anymore. So it will be the lateral area. So if we will now let A be the lateral surface area of the tent. By formula, lateral surface area is, again, originally it's 1/2, or we get the formula. Where is that? Let's just refresh our, here. Here's the formula. Lateral area is pi RL. Lateral area is pi RL, radius, and then the slant height. So area is pi RL. So R is already given, and this is now our L, which is our slant height. So meaning, what is missing in the problem? We already have R. R is 9, but we don't have L yet. So solving now for L, where do we solve for L? Okay, solve for L. We get L from this right triangle by the Pythagorean theorem. L will be the square root of 15 squared plus 9 squared. That will now be your L, coming from this right triangle here. So by the Pythagorean theorem, L will be 15 squared plus 9 squared. So again, if you have already the value of L, just go back here. Therefore, your lateral area is pi, your r is 9, and then your L is this value here. Just substitute whatever value you compute here. That's now your area. So that's the area. We're done with the area. Of course, the answer here will be in square feet. So if that's in square feet already, then the total material used will be, remember, sabi rito, 10% of the material is wasted. So 10% of the value that we get here will now be the material wasted. Therefore, the total material is we get our A multiplied by, isn't it that 100% is 1? Then get another 10% of that. So that will be 110% or 1.1. So multiply your A, isn't it? You will be able to compute your A here. Substitute it here, multiply it by 1.1, you get your total material. Again, this is in square feet. But since the question is in how many square yards, then just convert your square feet to square yards. Just look at the conversion factor given in your module. Okay, so that's it for some examples for similar figures and for our codes.